This is 8.8, Solving Inequalities. So the addition and subtraction properties of inequalities are pretty much the same as working with equations. We just have a different symbol in the middle instead of the equal sign. So if we add or subtract the same number on each side of an inequality, the inequality remains true. I can test that with regular numbers, where I know that 2 is less than 4. And if I add the same number on each side, I still get something that's true. 3 is less than 5. So if I have x minus 3 is greater than 9, and I need to get x by itself, I'm going to do the opposite of subtracting 3, and I'm going to add 3. These are inverse operations. They cancel each other out and leave the variable by itself. We could also say that we're going to move the 3 to the other side, which leaves x is greater than 12. If I have x plus 6 is less than 13, I'm going to subtract 6 on each side, and I get x by itself and have x is less than 7. The properties are also true for the greater than or equal to and less than or equal to. So we're going to solve and then graph the equation. Graph the solution. For x minus 5, I need to do the opposite of subtracting 5 and add 5 to each side to leave x by itself and get x is greater than 6. And then here's my graph to match. You can check out how to graph in 8.7, and there's more details on how this graph is structured and how we get there. For 2 plus x is less than or equal to 7, I need to get x by itself, so I need to do the opposite of this positive 2 and have negative 2, or subtract 2. 2 minus 2 is 0. 7 minus 2 leaves 5. So x is less than or equal to 5, and here's the graph. I have 10 is greater than or equal to x minus 1. Opposite of subtract 1 is adding 1, which leaves x by itself to be 11 is greater than or equal to x. And there's the graph. And here I have 30 is less than x plus 18. I'm going to subtract 18 on each side to get 12 is less than x. And here's its graph. When we multiply or divide, the properties of inequalities work the same as they do for equations, for positive numbers at least. So when we multiply or divide each side by the same positive number, the inequality remains true. So if I have 3 is greater than 2, and I multiply each side by 4, 12 is greater than 8, and that is still true. So I can try that with variables as well. X divided by 3 is greater than 2. The opposite of dividing by 3 is multiplying by 3, so I multiply each side by 3 to get x is greater than 6. For 3x is less than 12, right now 3 is being multiplied by x. Because they're right next to each other and you don't have any symbols, we know that means multiply. The opposite of multiplying by 3 is dividing by 3. To divide each side by 3, I get x is less than 4. So we're going to do a couple examples of this. We are going to solve and then graph the solution. So I have x over 6 is less than 2. This is division, so you do the opposite of dividing by 6 and multiply each side by 6. And remember, when we multiply with fractions, we would do straight across the top, straight across the bottom. So that means that I have x is less than 12, and here's the graph to match. Here I have 5x is greater than 15, and we do the opposite of multiplying by 5, which is happening right now, and I need to divide each side by 5. 15 divided by 5 is 3. 5 divided by 5 is 1. So x is greater than 3. And here's the graph to match. I have 2/3 x is greater than 4. To divide by this fraction, because 2/3 is being multiplied by x, to divide by a fraction you need to multiply by the reciprocal, which means that you flip it and multiply. Then we multiply straight across the top and straight across the bottom for each. 2 times 3 is 6, 2 times 3 is 6, 4 times 3 is 12, and 1 times 2 is 2. 6 over 6 is 1, so I have x is greater than 6, and here is my graph. And I have 5 is greater than 5t, so I need to, 5 is greater than 5t over 6. So I can split this to be 5/6 times t, and then I would need to multiply by the reciprocal on each side, and I would get 30 over 5 is greater than 30 over 30t. 30 over 30, anything divided by itself makes 1. So if top and bottom are the same in a fraction, that's just another way to write 1. So then I get 6 is greater than t, and I have a graph. Now I have 3/4 t is less than 24. So again, we're going to multiply by the reciprocal on each side. Multiply your fractions straight across the top, straight across the bottom, and I get t is less than 32, and a graph.